Welcome back to the channel. Smith here again. Today we're talking about inequalities, how you solve them, what the inequality signs mean, how you display them on number lines, all that kind of good stuff. So first things first, inequality signs. Now, you've got 4 inequality signs that you need to know the meanings of. I'm going to give you a few seconds to think about those while I write this down here. Now, in English, we always read from left to right, don't we? So we're going to read whatever's here, then the symbol, then whatever's there. Okay? So your first one, this one that I coloured down a lovely shade of purple there. This one. That is the greater than sign. Bigger than or more than. Greater than. So if you have something here, let's call it X, and something here, 17, the way you would read this phrase, this little bit of maths, this bit of algebra I suppose, the way you would read that is X bigger than 17, or X is greater than 17, X is more than 17, X is greater than 17. We don't know what X is, but we know it's bigger than 17. Now the one below it, in red, this one, because it's facing the other way, but it's the same symbol, this is the less than or smaller than. So if we have something here like this, the way you would read that is y is less than 12.5. Y is less than 12.5. Now the other two, you'll notice, I've got a little line underneath them like that. Okay? Makes it look a little bit like an equal sign. What these two mean is the same as the first two, but I should get them the same way around, shouldn't I? That make more sense. Mean the same as the first two. So here we've got the greater than symbol. So this one means greater than, just like it did over there on the left, or equal to. So greater than symbol and a little sort of equal symbol in the same place. For example, if I've got this, 14, you would read that as X is bigger than or equal to 14. So it could be 14, could be 15, could be 17.6, could be all kinds of things. And the final one looks like a less than symbol here, but it's also got the equals bit, so it's less than or equal to. So if we had something like Z, symbol 12, that just means Z is less than or equal to 12. So it could be 12, could be anything less than 12. Don't know what it is yet, but we know it's less than 12 or equal to 12. Now sometimes they'll come in pairs, where you get something like this. Again, reading from left to right, we're going to say 13 is less than X, and at the same time, X is less than or equal to 19. Another way of thinking about it is that X is between 13 and 19. But it can be equal to 19 because of the little equals bit there. Can't be equal to 13, so it's between 13 and 19. It can be equal to 19. So that's the only kind of arrangement where they'll come in pairs. And it'll always be both of them facing, pointing with a little pointy end to the left like that. Now, what do we do with these things? Well, here's a typical GCSE foundation level inequalities problem. We have to solve this inequality. Now, the way to do these is just completely forget that it's an inequality sign. Just imagine that it's an equal sign. Okay, and I'm going to separate that off from what we're actually doing. Now, to solve this, which is an equation, of course, just do what you normally do for solving equations. So the first thing, you're going to have to get rid of this 7 here. I'm going to take away 7 on both sides of the equal sign. What we're left with over here is 4x. We've taken away the 7. And on the right hand side, 2 take away 7, that's negative 5 or minus 5, isn't it? I could maybe write that a bit better, couldn't I? Negative 5, minus 5. Now we want x by itself. Here we've got 4 times x, so the opposite of timesing by 4 is to divide by 4. So just divide by 4 on this side, and that will leave us with x all by himself. Minus 5, negative 5 divided by 4 is negative 1.25 or 1 1/4, depending on if you like fractions or decimals. Now, that's all fine when it's an equal sign in the middle, it's just an equation. When it's an inequality sign, we literally do it exactly the same way. In fact, if you want, you can just scribble over the top there, make it do an equals, same steps. So we're going to take away 7. We're going to divide by 4, exactly like we did there. And then we're literally going to go back and rub out the equal signs and pop in the sign that we had, which was a greater than sign. There we are. So the solution to that question, 4x plus 7 is bigger than greater than 2. The solution to that is that x has to be bigger than, greater than, negative 1.25. X is greater than minus 1.25. We don't know what x is, it could be any value bigger than that, but that's our solution. Now, just like equations get more complicated, inequalities get more complicated. It's got more complicated because our unknown letter, which is n here, is on both sides. We're going to do exactly the same thing, just pretend it's an equation, and then go back and put the sign back to what it was. Make it into an equal sign. If we're going to solve that equation, you've got the problem of having n things on both sides. So we're going to get rid of the smaller of those, which is the 11n. We're just going to take away 11n from both sides. Take him away from this side as well. And what we're left with over here, we had 14 n's, we took away 11 of them. We've got 3 of them. We had 11n, we took away 11n, that's gone, we just got the 6 left. Now that's 3 times n, we want just one n by itself, so we're going to divide both sides by 3. And what we finish with over here, 1n, 6 divided by 3 is 2. There's your solution. Now, it wasn't, of course, an equals there, was it? So we'll go back, get rid of those, and then just pop in the correct symbol, which is here. So the solution of this inequality is that n, the number, has to be bigger than 2. Any number bigger than 2 will make that work. Just think of them exactly like equations, and then just go back, whack in the symbol that you need. Now another thing they might ask you to do is to write down the integer values that make a thing work. Now the word integer you should have come across, but if you haven't, all that means is whole numbers. 1, 2, 3, 4, 5 like that, not 1.7 or anything mad like that. Whole numbers can be negative, can be positive. So we have this inequality. we have to write down the whole numbers that x could be, which make this true. So if we just read the inequality, I'll write it down again. Negative 2 is less than x, that's less than or equal to 4. So x has to be between minus 2 and 4, but it can be equal to 4, but not equal to minus 2. So I'm going to write down a list of whole numbers that this could work for. Now it can't be equal to minus 2 because it has to be satisfying this inequality symbol. There's no equals bit on there. So the smallest it can be is minus 1. It can also be 0. It can also be 1. It could be 2. It could be 3. And because of that equal bit on this symbol, can be equal to 4. There we are. So we're literally just writing down a list of values, whole numbers, which make that inequality work. And that was a very simple one. They almost gave us the answer. Sometimes you might need to solve an inequality like this and then write down the values. Now, if you're not writing down a list of numbers or solving inequalities, the only other thing you can be asked to do is to display an inequality on a number line. So we have an inequality here, y is less than or equal to 1. We have a number line, which is just a line with numbers on it, whole numbers. And the way we display inequalities is like this. So if y is less than or equal to 1, somewhere above the line, doesn't matter exactly where, we're going to put a blob at 1, because it's 1. Now y is less than or equal to 1, the numbers that are less than 1 are down this way, aren't they? So we put from our blob an arrow pointing down that way. Okay? So that means y can be starting from 1, it's less than 1, it's pointing down that way. If you look at the inequality sign there, that's exactly the same as the arrowhead, isn't it? Going that way, going that way. So if you forget which way to draw your arrows, look at the inequality sign, exactly the same. Now, because it can be equal to 1 as well, we show that on the diagram by shading in the blob. So fill in there. So a filled in blob means can be equal to it. A blob that's not filled in would just be less than or equal or greater than, depending on which way it's going. Another example, they give you the inequality on the number line, you have to write down what it is. First of all, what letter do you use? Is it y like it was last time? We look here, it says x. Sometimes I'll write the x above the arrow there, sometimes it's on the axis. Sometimes it won't tell you what letter, and you can use whatever you like. So this one is x. It's got something to do with minus 1, because that's where the blob is. And we know it's pointing that way. The arrowhead pointing that way. Is the blob filled in? No, it's not. So it can't be equal to minus 1, it's just greater than minus 1. So this inequality on the number line, x is greater than minus 1. Simple. I think we've done that one already. So let's find a slightly harder example like this. Solve the inequality. Minus 12 less than or equal to x. Make it 2x. And that's less than 3. Now, for solving inequalities, as we did earlier, you can, if you like, solve this one, and then come back along, solve this one, because there's sort of two inequality signs, there's two things to solve there at once. But it's more straightforward, really, if you just solve them all in one go. So if you imagine solving this one, you're thinking about the equivalent equation, which is minus 12 equals to 2x, and all you would do is just divide by 2 because it's 2x. So we're going to do the same here, but we're going to do the same to both sides, both inequality signs, both parts of the equation. So all 3 bits of this weird looking thing. So we're just going to divide everything by 2 because it's 2x there. So I'm dividing that by 2, I'm dividing that by 2, and of course I'm dividing this by 2. So I get minus 6 there, inequality sign. 2x divided by 2 is just x, and this divided by 2 is 1.5 or 1.5. So there's our solution. Minus 6 is less than or equal to x, and x is less than 1.5 or 1.5. Now if you wanted integer values for that solution, you would simply list them out. So it can be starting from minus 6 all the way up to 1.5, 1.5, and x is between those. It can be equal to minus 6. So we can start from minus 6, minus 5, minus 4, minus 3, 2, minus 1, 0, 1. Now, can't be equal to 2 because that's too big. We can't put 1.5 here because that's not an integer value. So there is the full list of values it can be. Minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, and 1. I hope that's helped clarify inequalities a little bit for you. There's really nothing to be scared of. It's simply like solving equations. Sometimes you're doing 2 at once. Sometimes you have to draw them on number lines. Sometimes you have to write out lists of whole number solutions. But if you think of them just like equal signs, it equals equations, it makes everything very clear. If this video has been useful to you, please do consider subscribing to the channel. There'll be many more videos appearing, lots and lots of topics, lots of subjects that might help you with your maths. If you could hit the like button, that tells YouTube that people like the video and it's helpful, it will promote it to you and other people. On this channel in the future, I'll be guiding you through all topics in GCSE Maths, A-Level Maths, one topic at a time using exact copies of exam paper questions. Watch all the videos, do some practice of your own. You'll be in a really good place when you walk into the exam room. If you'd like a video on any topic I've not covered yet, do let me know in the comments and that will magically appear. As I said, like the video, subscribe to the channel, stay updated, you'll get notifications when new videos appear. Your exams will thank you for doing that. Thanks for listening, I hope that helped.